We've learned how to graph by finding intercepts, and finding intercepts is a great way to graph, especially if your equation is in standard form. But what if you have an equation that's not in standard form, like this one, y equals 1/3 x plus 2? We still graph by finding some points to put on our Cartesian plane. We have to be a little more selective in what we pick, especially if our graph has a variable like our x here that is being multiplied by 1/3. Since the equation here is solved for y, meaning y is by itself, it's easiest to pick some values for x, substitute those values in, and then solve for y. Okay, so what values should we pick for x? Well, let's make a table. We're going to pick a few values for x. We're going to substitute those values in and solve for y. And right away, the first value I like to pick for x is 0. Not only do I like to pick 0 because it's going to give us the y-intercept, but I also like to pick it because multiplying something by 0 really simplifies the problem. So our y is going to be 1/3 times 0 plus 2. 1/3 times 0 is 0, and 0 plus 2 is 2. So when x is 0, y is 2. Let's go ahead and put that point on there, 0, 2. Okay. So our second x coordinate that we're going to choose, we have to be a little more careful. I don't want to choose the number 1, for example, because then I have to do 1/3 times 1 plus 2, and my answer would be a fraction or a decimal. I don't want to graph a fraction or a decimal because I have to estimate where that point would go. So instead, I want to choose a value of x that's going to multiply by 1/3 and come out to be a whole number. And so I'm going to choose 3. I think 3 is a really good number because 1/3 multiplied by 3 is 1. So I'm going to do 1/3 multiplied by 3, which is 1, and 1 plus 2 is 3. So when x is 3, y is 3. So let's put the point 3, 3 on here. So 3, 3. We can stop right there. We only need 2 points. But when I'm given the option, I like to go ahead and get a third point. And the reason I like to get a third point is to make sure the first two are correct. If I get a third point and my third point ends up being here, for example, I know I have messed up on one of my 3 points because they do not make a straight line. If I stop at 2 points, I won't know if I made a mistake because, of course, you could draw a line through 2 points. But to draw a line through 3 points, all 3 of those points have to be correct. So let's go ahead and pick one more point just to double check ourselves. So there are 2 really great options here for a point to choose. One really great option is the point 6 because 1/3 times 6 comes out very nicely, and that would be 1/3 times 6 plus 2. 1/3 times 6 is 2, and 2 plus 2 is 4. So that's a really good choice. Another really good choice that you might be thinking of would be the point -3, if you're brave enough to do negatives, because 1/3 times -3 is -1, and -1 plus 2 is a +1. So we just need 1 point. Either one of those are good. If you're cool with negatives, that point is a good one. So -3, 1 would be a good point. And also 6, 4 is a good point. Either one of those are good. So we're overachievers here. We got 4 points. They're all in a straight line. That makes me feel confident that we did these correctly. Let's go ahead and connect our points to get the graph. There it is. And we'll go ahead and put arrows on the end to show that this graph keeps going. And there it is. That's how you make a graph from a table when it's not in standard form. You just choose some values for x and solve it for y, or we could have gone the other way. It was just easier to pick values for x in this case. And I recommend you get at least 3 points so that you can see all of those points are in a straight line. That tells us, gives us some confidence at least that we have done all of these points correctly.